It begins not with an answer, but with a quiet unease, a moment when a familiar story no longer fits as neatly as we were taught. History, after all, is not only a record of what happened. It is a record of what survived long enough to be remembered. For generations, we have told ourselves a comforting narrative. Humanity began simply. Stone gave way to bronze, bronze to iron, ignorance to knowledge. Each century climbed a little higher than the last. Progress, we believed, moved in one direction only, forward. Yet scattered across museums, buried beneath cities, sealed in stone, are objects that do not follow this orderly ascent. They are not myths or metaphors. They are physical things. You can weigh them, measure them, rebuild them. And when you do, they whisper an unsettling suggestion. Perhaps our past was not as linear as we assume. Imagine standing at an archaeological dig. The earth is opened layer by layer, time compressed into bands of dust and stone. The deeper you go, the older the world becomes. Expectations settle in. Cruder tools, simpler marks, fewer ideas. Then suddenly, something precise, something elegant, something that feels out of place, as if it belongs to a later chapter that somehow slipped backward into the story. These are the moments that disturb historians most, not because they are dramatic, but because they are quiet. A copper cylinder sealed inside clay, a pattern cut into granite with unwavering regularity, gears meshed so finely they could track the heavens. Each one forces the same question again and again: how? This documentary is not about rewriting history in bold strokes. It is about listening more carefully to it, about pausing where the record grows uncertain and resisting the urge to rush past discomfort. Because uncertainty is often where understanding begins. Across continents and centuries, ancient builders, engineers, and thinkers left behind traces of insight that seem far ahead of their time. Not miracles, not magic, but applied knowledge, careful, tested, repeatable, knowledge that worked. What makes these discoveries unsettling is not that they exist, but how easily they are explained away. Labeled anomalies, declared accidents, filed into footnotes. The objects remain, but their implications are softened, contained, made safe. Yet safety has never been the engine of discovery. Curiosity is, and curiosity demands we ask not only what an object is, but why it was made, and what kind of mind was capable of making it. Consider how fragile knowledge truly is. A library burns, a city falls. A craft is no longer practiced because the people who practiced it are gone. Within a generation, mastery becomes rumor. Within a century, myth. Within a millennium, silence. We often imagine ourselves as inheritors of all that came before. But history suggests something more fragile, that civilizations rise, accumulate insight, and sometimes lose it again. That progress is not guaranteed. That forgetting is as human as remembering. This is not a story about hidden masters or lost empires ruling the world. It is a story about people, about curiosity pressed into clay, stone, metal, and crystal, about solutions discovered through patience and observation, about minds working within their time and perhaps beyond it. As we begin this journey, hold on to one simple thought. If even a fraction of this forgotten knowledge once existed, what does that say about us, about what we may yet lose or rediscover? History is not finished speaking. We have simply grown accustomed to hearing only the parts that reassure us. What follows is an invitation to listen again, to the gaps, the contradictions, and the quiet artifacts that refuse to stay in their assigned place in time. The past may not be as distant as we think, and it may still be asking something of us. It was buried in the soil of Iraq, beneath layers of earth and assumption. In 1936, workers near Baghdad unearthed a clay jar, unremarkable at first glance, 5 inches tall, sealed with asphalt. Yet inside this humble vessel lay a copper cylinder, an iron rod, and the trace of acidic liquid long evaporated. It was not decorative, it was functional. When researchers later examined it, the configuration triggered a realization. This ancient jar resembled a battery, not metaphorically, but mechanically. It had all the components necessary to generate electrical current. When replicated using materials available in Mesopotamia 2,000 years ago, grape juice as electrolyte, copper and iron as electrodes, it produced measurable voltage. A quiet hum from the past flickering through the wires of now. The implications are uncomfortable. If this object, created 2 centuries before Christ, could produce electricity, what was it for? What was it powering? Texts from the region speak of eternal lights in temple sanctuaries, flames without fuel. Artifacts bear signs of electroplating, a process requiring steady current. This was no isolated curiosity. Multiple similar devices have been discovered following the same structure. Not artistic whim, but a blueprint, a design repeated. Yet academic response has been cautious, even resistant. The prevailing theory suggests the jars were for storing scrolls, though their sealed interiors and chemical residues argue otherwise. Proposals to test the remaining materials for electrochemical reactions have often been declined. The original artifacts, many of them, are now lost, damaged, or disappeared during regional conflict. Without them, questions linger, unanswered. There is a quiet tragedy in the way knowledge is sometimes treated as something to be contained rather than explored. The Baghdad Battery, as it came to be called, has become a symbol not just of forgotten technology, but of our reluctance to entertain the unfamiliar. We tell ourselves electricity began with Franklin's kite, with Volta's piles, with Edison's bulb. But here it was, humming softly in a Mesopotamian jar, overlooked for nearly 2,000 years. A technology used not to transform the world, but to fulfill a specific, possibly sacred function, and then, like so many things, lost. Perhaps that is the lesson. That knowledge is not always a march toward dominance. Sometimes it is a moment of insight, applied just long enough to serve a purpose, then set aside, its context forgotten, its meaning faded. And so the battery becomes more than an anachronism. It becomes a question. What else have we misunderstood because we expected it to look like progress? Imagine the quiet flicker of a temple light, burning without flame. The priest who knows the secret. The artisan who builds the jar. The people who use it, not as a revolution, but as a tool, just one part of their world. Then time moves forward. The temple collapses, the language shifts, the story changes, but the jar remains. It reminds us that our timeline may not be as neat as we think, that discovery does not only belong to the present, and that sometimes a forgotten technology waits patiently in the ground until someone, centuries later, finally listens to what it was trying to say. In the heart of Egypt, where the desert winds whisper through ancient ruins, stand monuments carved from stone so hard they challenge not only our tools but our understanding. Among these are granite blocks drilled with a precision that feels eerily modern. Perfectly circular holes, spiral grooves etched with unwavering regularity, and core samples pulled from within the rock that defy replication even today. Granite is not forgiving. It is one of the hardest materials on Earth, ranked 6 to 7 on the Mohs scale. The tools available to the ancient Egyptians, primarily copper and bronze, fall far below it. By every measure of modern materials science, these metals should have been incapable of carving such stone. Yet the evidence remains, etched in stone that has endured for millennia. What puzzles engineers most are the drill cores, cylindrical samples extracted from the stone. These cores bear spiral grooves spaced with mechanical consistency. They reveal a feed rate, how fast the drill moved downward, that would be impressive even with today's machinery. 1 inch of depth for every full rotation of the drill. Hand tools, by contrast, leave uneven markings. The pressure fluctuates. The grooves wobble. But these ancient cores do not. They speak of speed, consistency, and applied force, of a machine. Even more baffling is how these grooves cut through granite's complex internal structure. Granite is a composite of quartz and feldspar, minerals with different hardness. A hand tool would bite deeper into the softer feldspar, creating irregularity. But the ancient grooves maintain perfect depth, as though the cutter was indifferent to the stone's variation. It's the kind of uniformity produced by diamond-tipped tools spinning with mechanical drive. The holes themselves, perfectly circular and uniform, show no signs of deviation, no wobble, no tapering. Their alignment is straight as a laser, and yet we are told they were made with handheld copper and sand. The prevailing explanation is that ancient builders used copper tubes and abrasive sand to slowly grind their way into the stone. But attempts to replicate this method have yielded only frustration. Modern efforts produce grooves that are shallow, uneven, and time-consuming. The ancient method, whatever it was, outpaces modern replicators by a factor of 10. This is not to say lasers buzzed in the ancient sands, or that modern machinery existed in Pharaoh's time, but it does force a different kind of reflection. Perhaps we have underestimated what ancient minds could achieve with methods now forgotten. Perhaps they found efficiencies in simplicity, leveraging principles of vibration, sound, or pressure that we have yet to rediscover. The precision suggests more than chance or brute labor. It suggests experimentation, repeatability, refinement, a scientific mindset applied long before the word science existed. In these ancient boreholes lies a quiet contradiction. We've built machines to match their quality, but cannot explain theirs. We've named it an anomaly, a mystery, a footnote in textbooks. But what if it's a clue instead? What if progress is not a straight line, but a spiral, one that drills into the bedrock of time, occasionally hitting veins of insight before looping again? Stone holds memory longer than words, and in Egypt's granite the memory is clear. Someone knew how to do this. We may not know who, we may never know how, but their work remains, unmistakable, undeniable, and whispering still beneath the sand. 2 miles beneath the ancient rock of South Africa, in mines carved deep into the Earth's crust, workers began to find something strange. Small metallic spheres, perfectly round, impossibly smooth, some etched with 3 parallel grooves encircling their middles like celestial belts. At first they seemed like curiosities, odd shapes amid the mineral layers. But as more were found, their consistency defied randomness. Each one was almost exactly the same size, about 1 to 4 inches in diameter. The grooves, where present, were evenly spaced and uniform, as if carved by a machine. And then came the most troubling revelation of all. The rock encasing them was dated to 2.8 billion years old. That date alone stretched belief. It predates complex life, predates animals, trees, even oxygen in Earth's atmosphere. It predates everything we think of as human by over 2 billion years. And yet here were these metallic spheres embedded in the rock, their surfaces untouched by time, their forms too deliberate to dismiss. Scientists analyzed their composition. The material was a nickel-steel alloy, extraordinarily hard and unfamiliar in natural formations. This alloy in this purity doesn't occur without smelting, an artificial process that requires precise control of heat and composition. It's not something that happens by accident in the Earth's mantle. Skeptics offered natural explanations. Perhaps the spheres formed through volcanic action. Maybe the grooves were the result of pressure or sedimentary movement. But none of these theories could account for the regularity, the symmetry, the metallurgy. Nature, after all, is rarely precise. 1 or 2 anomalies can be ignored. But dozens, hundreds, still being pulled from the same layers of ancient stone? There is no evidence of tampering, no sign that these objects were planted, moved, or placed by modern hands. They are locked in place by geology itself, held firm by stone so old it predates the idea of civilization. Museums display them under glass, labeled as geological oddities. But the placards offer no answers, only dates, measurements, and a silent unease. If these spheres were made by intelligent hands, those hands must have existed before even the simplest multicellular organisms emerged. That is the conclusion science cannot face, and so the spheres remain unclaimed, too old to be artifacts, too precise to be accidents. Perhaps they are not relics of a lost civilization, but relics of a lost understanding, a sign that Earth has lived through more than one story of intelligence, that we are not the first to ask questions or to vanish, or perhaps they are something else entirely, a natural phenomenon so precise it forces us to redefine what we mean by natural. In the end, the spheres sit quietly in stone and in glass cases, offering nothing but their shape and their silence. And in that silence, a question lingers. If these are not evidence of another time, another intelligence, then what are they? And if they are, how much have we truly forgotten? The sea kept its secret for nearly 2,000 years. Beneath the waves off the coast of Antikythera, a Roman-era shipwreck waited silently, its wooden beams long rotted, its treasures scattered among coral and stone. In 1901, sponge divers stumbled upon it, fragments of statues, amphorae, bronze arms. But it was one unassuming lump of corroded metal that would later change how we view the ancient world. For decades, the object sat in a museum, oxidized and ignored. Then, in the 1950s, X-rays revealed a staggering truth. Inside this crusted bronze was a network of interlocking gears, over 30 of them, delicately cut, perfectly meshed, forming a mechanism of unimaginable precision. What lay before researchers was not a navigational trinket, but a complex analog computer built in the 1st century BCE. Its purpose? To calculate the positions of the sun and moon, to predict eclipses, to track the cycles of the planets, and even the timing of the Olympic Games, all with gear trains and dials operated by a single hand crank. It was an astronomical machine, an ancient orrery far ahead of its time. What made the device even more astonishing was the level of craftsmanship. The teeth of the gears were cut with precision so fine they rivaled those of 18th century clocks. The layout used differential gearing, a principle believed to have been discovered over 1,000 years later. The ratios encoded into the wheels matched known celestial cycles calculated by Greek astronomers. This was not accidental complexity. It was engineered knowledge, embodied in bronze. Attempts to recreate the mechanism using only the tools available at the time have proven daunting. The intricacy requires more than simple lathes and chisels. It requires an understanding of mathematics, astronomy, and fine metalworking, skills we rarely associate with ancient Greece on this scale. And yet here it is, a device so advanced that it would not be matched again until the mechanical clocks of the 14th century, a technology that appeared fully formed, then vanished from history for over a millennium. What happened? Did its makers guard the secret so closely it died with them? Were other devices melted down, lost to fire, war, or simple neglect? Or was the knowledge deemed unnecessary in an age that turned toward simpler truths? The Antikythera Mechanism poses more than a technological question. It challenges the narrative of progress. It forces us to consider that ancient minds may have seen the sky not with wonder alone, but with calculation, that they turned the heavens into ratios, cycles, gears, and from those built a machine. Perhaps the most haunting realization is that this mechanism was likely not unique. References in ancient texts suggest other machines like It may have existed. If so, where are they now? Lost to corrosion, buried beneath centuries, or simply unrecognized? The sea gave us one glimpse, one voice from a forgotten workshop, a whisper of what was possible and what might still be hidden. The Antikythera Mechanism does not merely belong to the past, it is a message to the future, a reminder that complexity is not always born from modernity. Sometimes it is rediscovered. And as we marvel at this clockwork star map from the deep, we are left with a humbling question. How much brilliance have we buried, simply because we weren't ready to recognize it? In the dim archives of a Turkish palace, amid scrolls and relics, an old map surfaced in 1929. At first glance, it was a curiosity. Ink on gazelle skin, drawn in 1513 by an Ottoman admiral named Piri Reis. But as cartographers examined it, a quiet unease took hold. For along its southern edge, the map showed something impossible: the coastline of Antarctica. 3 centuries before the continent was officially discovered, the map traced its shores, not as they appear now, buried beneath ice, but as they would exist ice-free, showing mountain ranges and inlets hidden for thousands of years beneath glacial cover. The more researchers studied the map, the more disturbing its implications became. The southern continent was drawn with accuracy verified only by 20th century seismic surveys. Its features, rivers, bays, ranges, aligned not with modern coastlines, but with the subglacial terrain uncovered by sonar and radar. Even the map's projection, a type of azimuthal equidistance centered near Cairo, required a level of mathematical knowledge no one believed the 16th century possessed. Piri Reis claimed he had not mapped the territory himself. Instead, he compiled it using older charts, some said to be centuries, even millennia old. He referenced source maps possibly dating back to the time of Alexander the Great. How could such knowledge have existed, let alone survived? The accuracy of the map extends beyond Antarctica. It displays the Atlantic coasts of South America and Africa in correct relative positions. It shows the contours of the Mediterranean and the Caribbean with remarkable fidelity. Small islands appear where they should. Latitudes are surprisingly precise. Skeptics argued the resemblance was coincidence, that early explorers had perhaps sailed farther south than assumed. But no ships of that era were capable of surviving the southern polar waters. And even if they had, they would not have seen beneath the ice. Some scientists went further. When the U.S. Air Force analyzed the map in the 1950s, they confirmed the Antarctic coastline matched their own seismic data obtained with modern equipment. They had no explanation. The question then becomes, if the source maps predate the last ice age, some 6,000 years ago, who created them? It would require not only long-distance maritime navigation, but surveying techniques, trigonometry, and a deep understanding of the Earth's curvature. Mainstream historians remain cautious. They suggest the map's precision has been overstated, that the resemblance to Antarctica is superficial. But even within academic circles, doubt lingers. Because if Piri Reis's map is based on older, accurate depictions of a once ice-free Antarctica, then history may be deeper than we think, more layered, more prone to erasure. Perhaps there was a time, brief and bright, when ancient seafarers mapped the world with skills we have forgotten. A time when the Earth was more familiar to them than we realize, and when the lights of their knowledge dimmed, only fragments survived, copied and recopied, fading into legend. The map is not a smoking gun, but it is a glimpse through a crack in the narrative, a piece of a puzzle that doesn't quite fit. It invites us to consider that memory is fragile, that civilizations rise and fall not only in ruins, but in what they remember or forget. And so, on a piece of gazelle skin, drawn with care by a man copying sources he did not fully understand, we may hold a ghost of a lost geography. A whisper from a time when the world was known, and then lost again to ice and time. Beneath crumbling temples and silent stone chambers, something else lingers, something not seen, but heard. In scattered sites around the ancient world, there are rooms that speak with sound. Places where whispers carry for impossible distances, where low tones cause walls to tremble, where the very air seems to sing in harmony with a single human voice. They are not accidents. One such chamber, carved entirely from limestone, drew the attention of researchers for a reason that had nothing to do with its carvings or age, but with its resonance. When sound was introduced at 110 Hz, the room responded. It vibrated, not metaphorically, but physically. The frequency echoed back with such strength that the space itself seemed to become an instrument. Modern acoustic engineers studying the chamber were baffled. The design should not produce this kind of response, not without precise shaping and material alignment. And yet, here it was, engineered, intentionally or not, to resonate at a frequency known today to influence human brain activity. Neurological studies show that 110 Hz affects areas linked to emotion, memory, and altered states of consciousness. In other words, it doesn't just sound impressive, it feels different. It shifts perception. Other chambers share similar traits. In one, a whisper carries effortlessly from one corner to another, amplified without any visible architecture to explain it. In another, echoes are entirely absent, as though the room absorbs sound selectively. Some even filter frequencies, enhancing male voices while suppressing female ones, or vice versa. These effects require control over acoustic principles, wave reflection, resonance, interference. They suggest an understanding of harmonic frequencies and spatial dynamics, what we today call sound engineering. But these chambers predate modern acoustics by thousands of years. Could ancient builders have discovered these properties through empirical observation, trial and error, or did they inherit knowledge already refined? What's clear is that acoustics were not a byproduct. They were the purpose. The chambers were shaped not just for space, but for sound. Walls smoothed to reflect vibrations. Dimensions tuned to harmonics. Entrances and gaps sealed to isolate resonance. Even more striking, many of these spaces are embedded deep within temples or tombs, places of ritual, meditation, or transformation. Sound here was not entertainment. It was experience. It was transcendence. Modern engineers using digital modeling and advanced materials still struggle to replicate the purity of these ancient acoustic environments. The technology may have changed. The challenge has not. We often imagine ancient people as bound by silence or noise, chanting in caves, shouting in stone halls. But what if they understood sound not as a distraction, but as a doorway? What if these chambers were built not just to house bodies, but to tune minds? The implications reach beyond architecture. They suggest that human history includes not just forgotten tools, but forgotten experiences, modes of perception shaped by space and frequency, lost when the chambers fell silent. And so we are left with this: a set of stone rooms humming with mystery, rooms that do not tell us what they were for, but show us what they could do. Perhaps in their silence they are still teaching, not through words, but through sound, through resonance, through the possibility that ancient knowledge did not always speak loudly, but it always knew how to listen. In scattered corners of the ancient world, where light bends through time and dust clings to forgotten shelves, lie artifacts that shimmer not with myth, but with impossible clarity. Crystal spheres, quartz lenses, and optically perfect shapes, crafted not by modern gem cutters, but by hands that worked long before the invention of electricity or the microscope. They are not decorative trinkets. They are precise, measured, and in some cases functional. One such object, a quartz lens unearthed from an Assyrian site, was found to have the correct curvature to magnify. Its surface was smooth, its edges exact. It focused light with little distortion. Under modern laboratory analysis, its optical qualities were revealed to rival those of today's commercial-grade lenses. Then came the spheres. Carved from crystal, flawless in their symmetry, these objects remain a quiet marvel. Creating a perfect sphere from hard quartz requires not just time, but an understanding of balance, of material resistance, and of removal, so even that no irregularities remain. Measurements showed tolerances within micrometers, deviations so slight that even modern machinery would strain to match them without digital guidance. Yet these were made with no known access to diamond-tipped tools or high-speed rotary equipment. No lathes, no lasers, just tools softer than the material itself, unless, of course, something else was used. When examined under magnification, these ancient artifacts showed an absence of typical tool marks. No scratches, no polishing striations, just smooth, uninterrupted surfaces. In some cases, internal features were present, channels cut within the crystal, suspended details that could only have been created by removing material from the inside without disturbing the outer shell. That's not art, that's engineering. Attempts to replicate the artifacts using tools from the presumed period have consistently failed. Modern gem cutters, even with access to abrasives and time, produce items with visible flaws and asymmetries. The ancient examples remain unmatched in precision and polish. What purpose did these objects serve? Some may have been lenses, tools for observation, possibly even in astronomy or medicine. Others might have been symbolic, ceremonial, or technological in ways we no longer understand. Were they part of larger devices, mechanisms now lost to corrosion and time? We may never know. But what remains is the evidence of mastery, not crude trial and error, but skilled, repeatable craftsmanship. A knowledge of crystal properties, of geometry, of optical behavior. Official explanations lean heavily on patience, that artisans, given time and determination, could achieve wonders. And yes, human hands are capable of astonishing things. But physical limitations matter. You cannot polish quartz to optical smoothness with copper and sand alone. Not to this level. These objects suggest more than effort. They suggest technique. Perhaps what we've lost isn't just the tools, but the approach. A way of working with material that treated hardness not as an obstacle, but as an invitation to precision. So we are left with these silent, shining puzzles. Lenses that may have once revealed the stars, spheres that may have once reflected a deeper understanding. Not supernatural, not science fiction. Simply, forgotten sphere, quietly waiting to be seen again. And in their glimmer, a question remains. What did they once help us see? And why did we choose to forget? Along the crumbling shores of ancient harbors, where waves have crashed for over 2,000 years, the ruins of Roman engineering still stand. Piers, breakwaters, docks, sun-bleached and sea-worn, but stubbornly intact. Against all odds, they have resisted the ocean's slow assault. Saltwater, storms, centuries of tide and time. And yet they remain. The secret lies not in the stone itself, but in what binds it. Roman concrete, long dismissed as primitive compared to our modern mixtures, turns out to be something else entirely. Smarter, stronger, and in many cases self-healing. A lost technology that has outlasted every skyscraper we've built. Modern concrete is a marvel of control, measured ingredients, precise formulas. And yet it fails. Within decades, cracks form, reinforcements rust, structures crumble, especially near the sea, where water and wind accelerate decay. But Roman marine concrete grows stronger over time. When scientists examined samples from submerged Roman structures, they found an extraordinary process unfolding. Volcanic ash mixed with lime and seawater didn't just harden. It reacted. Slowly, over centuries, mineral crystals grew within the cracks, sealing them, reinforcing the material from within. The Romans didn't merely stumble upon this. They chose their materials carefully, selecting volcanic ash from specific regions like Pozzuoli, known for its reactive properties. They understood which lime to use, how to combine it, when to pour it. They built for permanence. Today we call this process pozzolanic reaction, but the Romans never named it, they just knew it worked. And then somehow we forgot. After the fall of the Roman Empire, the formula was lost. For over 1,000 years no one could replicate it. Europe built with stone and mortar, then with bricks, then steel and modern concrete. But nothing matched the longevity of Rome's forgotten mix. Only recently have scientists begun to rediscover its chemistry. Using electron microscopes and molecular analysis, they are unraveling how the concrete heals itself. And still we struggle to match it, because it is not just a recipe. It is a practice, refined through generations. The implications go beyond durability. Roman concrete required lower temperatures to produce, meaning less fuel, fewer emissions. In an age of environmental urgency, it offers not only resilience, but sustainability. And yet, for all its brilliance, the knowledge was not written in glowing texts or guarded by mystery. It was passed through hands, through observation, through craft. Its disappearance reminds us how fragile knowledge can be. We assume progress is inevitable, that better things replace old things. But here the opposite is true. A superior technology was lost, not because it was hidden, but because the world around it changed and its value was forgotten. Now, as we rediscover what the Romans once knew, we're not inventing something new. We're remembering. And perhaps that's the quiet power of ancient knowledge. It doesn't beg to be believed. It simply waits. In seawalls and pillars, in harbors still holding the sea at bay. A reminder that intelligence isn't always loud. Sometimes it's built to last. Sometimes the ruins are still stronger than what we build today. In the rainforests of Colombia, amidst temple stones and burial sites, archaeologists uncovered tiny golden objects, each no larger than a child's hand. At first, they were catalogued as stylized animals, jaguars, birds, fish perhaps, but a closer look revealed something stranger. Swept-back wings, vertical tail fins, and fuselages shaped not like creatures, but like aircraft. The resemblance was uncanny. These were not crude carvings. The wings were centered for balance, the tails upright for stability, and the forms aerodynamic. They had the proportions and features of modern planes, yet they were made over 1,000 years ago, long before the first human flight. For decades, these so-called zoomorphic artifacts were dismissed as coincidence, artistic imagination, nothing more. Then engineers took interest. One aeronautical expert built a scaled-up model based precisely on one of the gold figurines. No changes, no interpretation, just enlargement. He added a propulsion system and tested it in a wind tunnel. It flew. The model was not just capable of flight, it was stable, responsive, and efficient. The wing angles, dihedral, tilted upward, were identical to those used for modern aircraft stability. The vertical tail fin provided directional control. The proportions of lift to mass were aerodynamically sound. This wasn't guesswork. It was design. Skeptics argue that any resemblance is accidental, that with enough stylized animals, some will appear mechanical. But the argument fails to address specifics. These features are not random. They follow aerodynamic logic. Dihedral angles don't improve the look of a bird. They improve its ability to stay in the air. Even more curious, the people who created these artifacts, likely part of the Quimbaya culture, had no known tradition of flight or machines. And yet they produced objects that align closely with principles not fully understood until the 20th century. The question isn't whether these tiny gold models are airplanes. They're not. They're symbols or representations, perhaps of myth, perhaps of memory. But what they depict seems more mechanical than natural. Were they inspired by visions, legends, or something else entirely? Something once seen, now forgotten? Ancient texts from nearby civilizations speak of sky gods, of flying vehicles, of beings who descended from above. These are often dismissed as metaphor, as mythology. But mythology often preserves truth in the language of the fantastic. We cannot say these gold objects prove the existence of ancient flight, but they force us to reconsider what was possible, what was remembered or imagined with such technical accuracy. They also remind us how easily we overlook the unusual when it doesn't fit our narrative, how quickly we file mystery under coincidence. Perhaps these figurines were never meant to be understood in our time. Perhaps they were echoes of something else, some glimpse of form or function passed down through generations, changing meaning as the context was lost. But there they sit, wings swept back, fins standing tall, flight frozen in gold, waiting for a sky that never came. In the end, they ask a quiet question. What if some memories are not myths, but blueprints, waiting to be recognized again? In a uranium mine in Gabon, West Africa, scientists stumbled upon a discovery that shattered expectations, not of what humanity could do, but of what the Earth itself had once done, or perhaps what had once been done to it. It was 1972, and a shipment of uranium ore was undergoing routine analysis. Technicians noticed something unusual. The uranium was depleted in U-235, the isotope necessary for nuclear fission. Naturally occurring uranium contains a specific ratio of isotopes, and this sample didn't match. It was as though the material had already been used in a nuclear reactor. That seemed impossible. Reactors are man-made. Controlled nuclear fission doesn't occur in nature. At least, that was the belief. So the scientists looked deeper. What they found was nothing short of astonishing. Within the rock were zones of uranium ore arranged in patterns that mirrored those in man-made reactors. The mineral layout, the presence of neutron-absorbing elements like boron, and even the geometry of the deposits all pointed to a conclusion no one wanted to accept. This was a natural nuclear reactor, one that had been active 2 billion years ago. It had operated intermittently, cycling on and off. Water seeping into the ore had moderated the reactions. When it boiled off, the chain reaction paused, only to resume when the stone cooled and water returned. This natural control system prevented runaway reactions, much like the shutdown procedures in modern facilities. But the story doesn't end there. As geologists and nuclear engineers studied the reactor zones more closely, the similarities to human-made systems grew uncanny. The uranium wasn't just randomly distributed. It formed compact zones, separated by materials that acted like reflectors and control rods. Clay layers served as containment barriers. Boron absorbed excess neutrons. The system maintained equilibrium over hundreds of thousands of years. Some called it coincidence, a perfect alignment of natural variables. Others weren't so sure. What if it wasn't entirely natural? The idea is controversial. The mainstream insists these were geochemical phenomena, but the level of precision, the geometry, the self-regulation, the presence of moderating and control materials raises unsettling possibilities. If not deliberate construction, perhaps deliberate manipulation. Could an ancient intelligence have discovered the fission process long before modern science caught up? It seems improbable. And yet, so does a naturally occurring nuclear reactor. This event forces a confrontation with the limits of our imagination. We assume that nuclear power emerged only once in the 20th century after centuries of scientific progress. But this mine, in its silent rock, suggests that fission has danced across Earth's surface before. That atoms have been split not just in modern labs, but in deep time. Whether natural miracle or lost intervention, the Oklo reactors, as they are now called, remind us that energy doesn't belong to the present. It is a force as old as the planet itself, and perhaps once it was understood, then forgotten. We build our future on the assumption that our discoveries are final, our knowledge unprecedented. But sometimes the Earth opens to reveal that we are not the first to ask big questions, and maybe not the first to answer them either. Across 10 chapters, we've traced a path through ruins, relics, and riddles, each artifact a paradox, each discovery a challenge to our carefully drawn timelines. But these objects do more than defy historical placement. They whisper of something deeper, the fragility of knowledge, the impermanence of progress, and the strange resilience of curiosity. Together they form a pattern, a battery sealed in clay, quietly generating current in ancient Mesopotamia. Drill holes in granite that bear the mark of high-speed, machine-like precision. Metal spheres locked in billion-year-old rock, carved with symmetry beyond nature. A computer from ancient Greece that could calculate eclipses with mechanical elegance. A map that knew Antarctica before the world did. Stone chambers that sing with perfect frequency. Lenses that see with clarity centuries ahead of optics. Concrete that grows stronger over time. Golden figures that fly. A nuclear reactor that operated 2 billion years ago. None of these things are theories. They exist. They have been measured, tested, photographed, replicated. The question is not whether they are real, it is what we are willing to believe about them. Modern responses follow a familiar rhythm. First comes denial. It's a hoax. Then dismissal. It's a coincidence. Then containment. It's misunderstood. Finally, silence. Rarely do we follow the evidence without resistance. Perhaps this is because these discoveries challenge more than history. They challenge the narrative of human uniqueness, that intelligence is recent, that progress is linear, that we are the peak of an upward slope. But what if history is not a climb, but a cycle? Civilizations rise and fall, empires bloom and crumble. Knowledge is gained, used, and then sometimes forgotten. Fires consume libraries, languages die. Masters leave no apprentices. And the world moves on, carrying echoes instead of blueprints. These artifacts suggest that in the distant past, there were peaks we no longer remember, moments of insight and invention that were not passed forward. Not myths, but memories encoded in objects. They also suggest something profoundly human, that we have always reached beyond what we were told was possible, that our ancestors were not primitive but inventive, not merely surviving but experimenting, discovering, wondering. We have been curious for a very long time, and now, perhaps, we are curious again. Because these objects have not changed, we have. We are finally learning to ask better questions, to accept that not knowing is not failure, it's invitation. What else lies beneath our feet, forgotten? What knowledge waits in unopened tombs, in miscategorized museum drawers, in ruins too quiet to draw attention? The story of humanity is not just the story of what we remember. It is also the story of what we've let slip through our fingers. In the next chapters, we'll explore not just the artifacts themselves, but what they reveal about us, about our memory, our blind spots, our need to explain away mystery rather than live beside it. We are not seeking certainty, only understanding. And perhaps in doing so, we begin to hear the past again, not as dogma, but as dialogue, not finished, not fossilized, but waiting. Imagine a long-forgotten workshop, stone walls darkened by time, the scent of metal and oil lingering in the air. A quiet figure leans over a workbench, turning a gear between calloused fingers. Outside, the world moves slowly, chariots creaking, sandals scuffing dust. But inside, something extraordinary is being built. The artifacts we've explored did not emerge by accident. Someone designed them. Someone tested, failed, adjusted, and tried again. Behind every impossible object is not just a mystery, but a maker. The Baghdad Battery was crafted by a hand that understood how acid and metal could produce light. The gear trains of the Antikythera Mechanism were cut by minds fluent in both math and movement. The precision-drilled granite, the crystal lenses, the tuned acoustic chambers, each required more than luck. They required process. It's easy to romanticize the past, to imagine forgotten civilizations as mythic or alien. But the truth is more intimate. These were people, craftsmen, thinkers, tinkerers, guided by need, by ritual, by curiosity. They weren't trying to amaze the future. They were solving problems in their present. And then something happened. A war, a fire, a generation without teachers, a shift in culture. The chain was broken. The knowledge faded. The archaeological record doesn't just show what was built. It shows what was abandoned. Tools buried beside tombs. Devices melted down for their metal. Techniques lost because no one wrote them down, or because no one left to read what was written. Even today, we forget. We lose code to obsolescence, skills to automation, languages to silence. We bury our own knowledge in complexity and call it progress. But there's a quiet hope here too, because each rediscovery is a reminder that human intelligence is not new, it is ancestral, and it never disappears entirely. It waits. Roman concrete, once lost, is being studied again for its durability and environmental benefit. Ancient lenses and acoustic designs are informing new approaches in optics and architecture. Even the Antikythera Mechanism has inspired a new generation of engineers to rethink what mechanical computing can be. We are not starting from scratch. We are remembering. And in this remembering, we are not just reconstructing objects. We are reconnecting with a lineage of thought that stretches back farther than our history books suggest. This is not a story about supernatural civilizations or vanished continents. It's about us, about what we're capable of, what we've lost, and what we might rediscover, if we're willing to listen. So the next time we stand before a strange artifact behind museum glass, or read a line in an ancient text that seems too advanced, we might pause before dismissing it. We might ask, what if this is not the outlier, but the echo? And what else still waits beneath the sand, the stone, the silence, ready to be heard again? So we arrive at the end, only to find ourselves at the beginning of something larger. These 14 stories of batteries sealed in clay, machines buried in the sea, maps drawn with impossible foresight, are not just tales of technology out of time. They are reminders, echoes of a truth we often forget, that knowledge is not guaranteed. It is fragile, flickering, like a flame carried through wind. History is not a ladder we climb, rung by rung. It is a tide. It advances, recedes, swells, and sometimes pulls away what once seemed permanent. Civilizations rise not only on land, but in thought. And they fall, not just through war or famine, but through forgetfulness. What remains behind are artifacts, objects out of place, traces of brilliance worn smooth by time. We often approach them with skepticism, as we should. But skepticism should not mean silence. To question is not to believe blindly, but to listen openly. We are told that these anomalies are unimportant, that they don't change the big picture, but sometimes it's the small pieces that reveal the most. A misfit object can unravel the thread of a larger story. A single gear can tell us that someone, somewhere, once knew how to build a universe from bronze and thought. What connects these discoveries is not conspiracy or fantasy, but human ingenuity. The persistent hum of curiosity across centuries, the willingness to try, to understand, to shape the world with what little we have and leave something behind in the process. In each of these artifacts, we see reflections of ourselves, our capacity to create, to dream beyond what we are told is possible, and also our tendency to forget. But forgetting is not final. We are now, perhaps more than ever, in a position to remember, with tools that let us look deeper, with minds trained to connect past and future. with voices ready to retell stories in ways that honor mystery without needing to solve it completely. The point is not that we've been lied to, it's that we haven't looked closely enough. The past is not fixed. It is unfolding, always. And so the question is no longer whether these objects belong in history. The question is, what kind of history are we willing to include them in? One that fears mystery or one that embraces it? One that edits out the strange or one that understands that the strange may be the most honest part of all? The future of our past depends on how we choose to remember, with arrogance or with humility, with certainty or with wonder. These objects are real. They are waiting, not for explanation, but for attention, for someone to see them, not as errors, but as invitations, to explore, to question, to begin again, not with answers, but with awe.